I'm going to show how to calculate how much heat is released or absorbed with chemical equations. So here I have a chemical equation that shows what happens when methane, also known as natural gas, burns in the air. So methane, CH4, combines with oxygen to make carbon dioxide and water. But as you probably know, if you burn methane, it releases a ton of heat. And that's what this delta H thing is over here. This number is telling us how much heat we're dealing with. It's 890.4 kilojoules, which is just a unit that we use to measure heat. Now, just in case you weren't sure whether burning natural gas releases heat or absorbs it, we have this negative sign here. The negative is telling us that this is an exothermic reaction, which means that heat is released. So we want to calculate how much heat is released by burning 27.5 grams of methane or natural gas. When I'm doing calculations that use chemical equations like this and use a lot of math, numbers, measurements that are in grams, like 27.5 grams, are not particularly useful. I really want moles. So the first thing that I'm going to do is I'm going to take 27.5 grams of CH4, and I'm going to convert that to moles. Here's how I'm going to do it. I'm going to use a conversion factor that includes the molecular weight or the molar mass of CH4. I'm not going to talk much about moles here, but there are other videos on that topic. So I have grams CH4 up here and I have grams CH4 down here. They're top and bottom, which means they're going to cancel out. And when I do the math, I'm going to get 1.72 moles of CH4. So now I know how many moles of CH4 I have. At this point, I can go up and take a look at this equation. Look at methane here. There's no number in front of it, which means that we have one CH4. You have one if there's not a number, right? We have one CH4 or 1 mole of CH4. 1 mole of CH4 and negative 890.4 kilojoules. What this means is that 1 mole of CH4 makes this amount of heat. Okay? So if I had exactly 1 mole of CH4, I'd know exactly how much heat gets released. But I don't have 1 mole. I have 1.72 moles. So what I got to do is I got to write this as a conversion factor and use this conversion factor to turn 1.72 moles of CH4 into an amount of heat. All right? So here's how I can do this. There are 2 conversion factors that I can write using this information. One of them looks like this. It's 1 mole CH4 over negative 890.4 kilojoules. Now I can also flip this, and I can write negative 890.4 kilojoules over 1 mole CH4. Both of these conversion factors are equally correct, but I'm going to be starting with 1.72 moles of CH4. And so I want to use a conversion factor that's going to cancel out moles of CH4 and is going to leave me with units of kilojoules. I'm going to want to use this one instead of this one. So I bring this over. You can see that moles up here cancels out moles down here. And now I'm going to do this math, which is this times this divided by 1, and I'm going to get 1,530 kilojoules. This is how much total heat is released when we burn 27.5 grams. Let's take a minute to look at the steps that we went through because we're going to have to use them for future problems, okay? The first thing that we did was we took grams of CH4 and we converted it to moles of CH4. We used a conversion factor that included the molecular weight in order to do this step. Okay? Then once we had moles, we used that to get kilojoules of heat. And we made use of a conversion factor that included this information here, that 1 mole of CH4 made this much heat, multiplied them, and that's how we got the total amount of heat. Let's do another example. Here we're going to calculate how much heat is created by 79.2 grams of oxygen. Let's think about the steps we're going to take real quick, okay? First, we're going to go from grams of O2 to moles of O2. We'll use a molar mass for that. and then we'll take moles of O2 and use that to get kilojoules of heat. Okay, so the first step is, we'll do this really fast, 79.2 grams O2. Multiply that by a conversion factor that includes the molecular weight. Grams of O2 cancels out because grams of O2 is down here. We do the math and we end up with 2.48 moles of O2. Now we can go up and look at this equation. Now this is really important. Pay attention here, this is important. In the previous example, we said that 1 mole of CH4 made 890.4 kilojoules of heat, okay? And we were able to use this information to write this conversion factor. But it's different with oxygen. Check this out. There's a 2 in front of the O2, okay? And so that means that 2 moles of this makes this much heat. So here is the statement for O2. Get it? 1 mole of CH4, but 2 moles for O2. 2 moles make this much heat. So when I'm talking about oxygen, I need to write a conversion factor that looks like this. 2 moles of O2 making this much heat, okay? Don't confuse the two of these. It all depends on the number that you have in front of the chemical. 1 here, 2 here, 2 and 2, okay? So we will use this conversion factor of 2 moles O2, or I can also flip it to get negative 890.4 kilojoules over 2 moles O2, all right? Now, which of these am I going to want to use? Well, I'm going to be starting here with moles of O2, 2.48 moles O2. I will want to multiply it by the one that's going to cancel these units out. So I'm going to choose this one. Now I have moles O2 up here, cancels out moles O2 down here. And now the math I'm going to do is this times this divided by 2 is going to give me 1,100 kilojoules. And this is my final answer. Now, let's do 2 practice problems where we go the other way. We start with a certain amount of heat and we figure out how much chemical we need in order to get that amount of heat. Here's an equation for nitrogen gas combining with hydrogen gas to make ammonia. This also releases a bunch of heat, as you can tell because the delta H number here is negative. We want to find out how many grams of N2 we're going to need in order to make this much heat. So here are the steps that we're going to go through to figure this out. The first thing that we'll do is we'll take the amount of heat that we want and use that to figure out how many moles of N2 we're going to need. We'll use a chemical equation and this number to figure that out. Once we've found out how many moles of N2 we're going to need, we can then use the molecular weight to figure out how many grams of N2. So let's start up here with the equation. There is nothing in front of N2, which means that we're talking about 1 or 1 mole, and this is how much heat we're dealing with. So the equation is telling us that 1 mole of N2 makes negative 92.6 kilojoules of heat. Okay? So there are 2 conversion factors that we can write with this information. One with N2 on the bottom, one with N2 on the top, and one with N2 on the bottom. I'm going to start with negative 550.0 kilojoules and choose the conversion factor that's going to get rid of kilojoules and leave me with moles. It's going to be this one, kilojoules on the top, kilojoules on the bottom. They cancel out, and when I do the math, negative 550 times 1 divided by this, I get 5.94 moles of N2. So now I have my moles of N2, and to take the final step from moles of N2 to grams of N2, I'm going to want to use a conversion factor that makes use of the molecular weight here, 28.0 grams. Moles N2 cancels there, moles N2 cancels there, and I end up with 100 366 grams of nitrogen in order to make this much heat. Here we're going to figure out how many moles of H2 we need to get negative 155 kilojoules. We're going to use the same plan of attack that we did earlier. We're going to go from kilojoules to moles using the information that's in this equation. And then once we have moles, we'll use a molecular weight to go from moles to grams. Okay? So the first thing we do to go from kilojoules to moles is we look up here at the equation. Okay? We are concerned with H2 with hydrogen here. And notice there's a 3 in front of hydrogen in this equation, which means that 3 moles of hydrogen make this much heat. So we'll write it like this. 3 moles H2 make negative 92.6 kilojoules of heat. So I'll be starting with negative 155 kilojoules, and I'll multiply it by a conversion factor that says this information. Okay, here it is. 3 moles on top, 92.6 kilojoules on the bottom. Kilojoules, kilojoules, they cancel out. I do the math. This times this divided by this is going to give me 5.02 moles of hydrogen. Now I'm halfway there. I'll take my 5.02 moles of hydrogen and I will multiply that by a conversion factor with a molar mass. I've actually done all of the work right here. Moles of hydrogen times conversion factor with molar mass in order to give me 10.0 grams of hydrogen, which is the total that I need. So I start with kilojoules, go to moles, and then go to grams. So 2 things that are important to keep in mind here. First, when you start with grams, that's not particularly useful. You're going to want to use moles. Okay, so the first thing you want to do is you'll want to convert grams to moles. The second thing, that's probably even more important, is to keep in mind that you want to look carefully at the number, the coefficient that's in front of the chemicals here in the equation. If it says 1, that means 1 mole of nitrogen makes this. If it says 3 here, it means you need 3 moles of this to make this much heat. And so the conversion factor that you use is going to depend on the number in front of the reactants or products in the equation.